Hello folks, this is the video tutorial for homework 3 uh, of the lab 51 for the course. Okay. Now remember that these problems from lab to lab, they're different. So of course I'm going to show you the stuff here, but I advise you also to look at the other video segment for the other labs. Okay. There are two problems here, and you have to submit problem number 1. The specifics are given there. You look at this, immediately you should realize that you must be using shell elements to do this problem. The thicknesses are given, and the vertical thicknesses, the thickness of the vertical walls is different from the horizontal ones, and these plates are subjected to some pressure, and this hole, the hole is fixed, is clamped. Okay. When you think about the problem, just think about it, stare at it for a while. You'll notice that actually you need to model only 1/4 of that. You can make a cut this way and you can make a cut that way. So you need to model only 1/4 of that. Now, I will model the whole thing and then I will cut it with a split command to show you some of the features. And it's up to you though. I mean, if you want to model 1/4 of it and then proceed, that's fine. Now, the other thing is the second problem is over here. So you have uh, basically a folded sheet metal or a box, thin walled box, which is the bottom of it is clamped, and then you apply a displacement of point oh 0.001 inch along this diagonal line, and you want to model it. In this particular problem, there's half symmetry, so you model only half of this, and I will use the local coordinate system to do that. Okay, so let's actually worry about this one first. Okay. So I'm going to go to CATIA, make a part, and immediately save it. So we have File, Save Management, Save As, Desktop, New Folder. I'll call this thing Homework 3, Lab 52. Sorry, 51, Lab 51. Okay, put the stuff in there. And I will call, since I'm going to be doing two problems, your student ID number, 1, 2, 3, 4, 5, 6, 7, 8, 9. Your last name, Bernoulli. Problem 1. Problem 1. Okay. And please keep in mind that there are many different ways to generate these geometries. This is what I would do. So on a convenient plane, on that vertical plane, I will sketch something that resembles that geometry, this thing, and then extrude it. So let me draw something like that, like so. Here, we're going to clean it up in a minute. Okay, let's make it symmetric. This control the middle axis. We make it symmetric. This corner point, control that corner point, control middle axis, make it symmetric. Let's do some dimensions here. The dimensions, this is 4. Actually, this is, I think it's 4. Let me check. Yeah, 4. Okay. This dimension is also 4. 4. And this dimension is also 4. 4. Okay, exit. And then I'm going to extrude it in both directions, mirror extend, 1 inch in each direction, so total of 2. Now, I'm going to draw my circles here, there, and there. Although I'm telling you that because I'm going to be cutting, I'm doing a lot of extra work for no reason. But that's how I'm going to do that. So on this plane, I will sketch. Okay, a circle. Where am I? Yeah. Let me see what I did. I forgot what I picked. Okay, let's do it on this plane. On this plane, I will sketch the circle of radius 0.5, diameter 1, diameter 1, exit, there we are. And then I'm going to use the split command. It says element to cut is that entire thing. And cutting element is this. And then repeat it. On this face, I will sketch things over here, something like that. Dimension it properly. And dimension from this point to that line is 2. Exit. Once again, you split that guy with this guy. Oops. This guy. Now it's nuts, but I'll draw it here too. But later on, I'm going to cut it, so this is all going to go away. So on this face, I will sketch. So this is going to be 1, diameter 1. And the distance from the center to here, we're going to make it 2, exactly halfway in the middle. 2, okay. Exit. And then split it. Split this with that. We say okay. Now, notice that I did not join, but when in doubt, if in doubt, you can always join, okay? Uh, I'll leave it to you, okay? So, yeah, I don't really need to join it in this particular problem, but that's fine. Okay, now let's cut it, okay? So split, read it carefully. Element to cut is that entire joint. Cutting element is this middle plane, and we keep this side, fine. Do another one. This entire joint, whatever is left of it, and middle plane here, and we keep the back side. Okay. Anything else that we don't want, we can always hide, okay? Anything that you don't want, you can hide. So these things, hide, hide. You can do control, select them, same time. Hide. Okay, very good. Let's apply material properties to this. So I think this problem said, what is it? I think it said steel, made out of steel. Yeah, good. So apply material, which is somewhere down here, right there. Metal, steel on that part. We say okay. Excellent. And this is it. So file, we already actually did the file save management. You just click on the floppy and it's going to overwrite it. So now we're going to go to generative structure analysis. We're doing a static analysis. CATIA does not see a 3D object. It's just going to tell you that you have to mesh it. So here is the shell mesh right there, and you select this. We join the whole thing, so the whole thing gets meshed. Even if you had not joined this particular problem, it would have worked fine. So let me make this thing smaller, maybe 0.2 parabolic. And you can look at your mesh here, right-click mesh visualization. See that? Okay. Deactivate the mesh. There's nothing you can do when this guy is on the screen. This is the mesh. You want to deactivate it. Okay. So this bottom circle is clamped. Okay. And then these are planes of symmetry. Okay. So let's uncheck all of these because. Okay. So here. Okay. So this edge control that actually you can, I think you can select them one. You don't need to use the control. So this and that, these four are plane of symmetry, and it lies in the XZ plane. So no displacement in Y. Oops. These lie in the YZ plane, no displacement in X. These lie in the YZ plane, no displacement in X, and rotation is opposite. So there we are. Okay. And then another one. This one is that plane of symmetry. This is a plane of symmetry. And that edge lies in the XZ plane. No displacement in Y, and opposite for the opposite for rotations. Okay, now notice that this particular problem, that wall has thickness of uh, that wall has a thickness of 0.2, where a horizontal one thickness of 0.1. So what I'm going to do is I'm going to use 2D property on that entire thing, and I put a 0.2 here, no problem. However, we know this is wrong, okay? This only applies to the vertical one. This horizontal one is a different one. So we go here, right click, 2D, local 2D property. You select this guy, and you select that guy, and you put 0.1 as the thickness. Okay? The reason that it has the right value is that I did it earlier for the other section. Good. Now what else do we have? This guy is subjected to a pressure of 50 psi. So where is the pressure here? Pressure on that face, 50 psi. Change that to 50. Say okay. Let's save the analysis. So file, save management. This is save as. What was that? Homework desktop, right? It was homework 3, homework 3 lab 51, and I give it the same name that I had for the part. So that's going to be ID number, your last name. This is problem 1. You have to use all planes of symmetry, otherwise you lose marks on a test, and we just did. Okay, we say all right. Oh, I forgot to say lab 51. That's okay. All right, run it. Assuming that we haven't forgotten anything. Who knows? Anything that you don't like, you can hide. These things you can hide. Okay, so deflection, it looks like that. You don't have to be a genius to see that this is correct as far as the overall qualitative behavior is concerned. As far as the deflection goes, right there, 2.9 inches, that's gigantic. So 2.9 inches for something that's only 4 inches long, this is, you generate the number, but this, it's not going to be correct because this is going to yield, and when material yields, then it's not going to go up. Anything that you do with material is no good, okay? And these are huge stresses, and that's because this pressure that you put on that is so big compared to this 1 millimeter thickness that basically it's garbage, okay? So this is it. We're done with this problem. Okay, so I'm going to close this. I'm going to close that. Now I'm going to show you the second problem. This you don't have to turn in, but I'm going to do it for you. Okay. So what we're going to do is we're going to create this geometry, and I'm going to do it directly without using solid object. Okay. And then we move on. And remember, there is a plane of symmetry here, and you have to either create half of this, yeah, or the whole thing and then delete it. I'll do it the long way, but I want to show you the significance of local coordinate system there. Okay, good. So let's start with this part file. Immediately save, file, save management, save as, your desktop, you have the folder, homework 3, homework 3 lab 51. This is going to be problem number 2. Your ID number hasn't changed, your last name hasn't changed, just the problem has changed. Okay, so let me make on this horizontal plane, I will make a rectangle, 10 inch by 10 inch. That was the size of that rectangle. Let's make it. This is 10. and then again 10 here, exit. Okay, so I'm going to pat this thing down. I'm going to pat it down. Okay, well, you can't pat it. I mean, if you're creating a surface, you're going to do extrude this in the other direction, reverse direction, and 0.5. Oh, was it 0.5? Wait a minute, can't remember. 2 inches, not 0.5. Okay, so double click, 2 inches. Okay, now I want to put a cap on top of that, so I'm going to use the fill right there. See that? Fill, F-I-L-L, for that sketch that you drew, and there we are. So basically, this is a box like that, okay? Now, I am going to join these, okay? Because right now, they're two separate surfaces, so I'm going to join these, and the joining is that top fill and the side extrude. Say okay. Okay. Now I want to cut it. In order for me to cut it, I need a plane here, and none of these planes can be used, so I'm going to use a plane like that. So a plane going through 3 points, 3 points, this point, and that point, and one other point here. Okay, you can see that at 45 degrees. And I'm going to split. See that? Split right there. It says, what is it that you want to split? That join. And with what? With that plane that I created. Doesn't matter which side you pick. I'll pick this side exactly like it is. Okay. Now, the problem is that this edge is neither in the x direction nor y and nor z. Okay, so when it comes to us specifying restraint, it's not possible to use x, y, z. So you create a local coordinate system. Here is the axis system right there in the tools toolbar, axis system. The origin, I'm going to put it right there. And the x-axis, I'm going to put it on this line. Okay, see that? So what happened is I created the local coordinate system that x is along that line and z is perpendicular to it. Okay, fine. This is fine. All right. Okay. So let us, let me hide this guy too. I don't want it. Hide it. Okay. This plane, I don't need it either. Hide it. Okay. Now, save it. Shows problem 2. Let's apply material properties to this. I think it was also, I don't know, steel properties. Where is it? Oh, right there. I think that was also steel. Metal. Yeah. Steel on the part. Say okay. Good. And save everything. Now we're going to go to generative structure analysis. We are using a surface mesh shell right there. You click on it. And, well, okay, so that's fine. Let me make it 0.5. How about that? If it's too small, we're going to change it. Okay, good. You want to look at your mesh? Right-click Mesh Visualization. There we are. Deactivate this. Deactivate it. Okay, the bottom is clamped. This and that are clamped. So clamp. Oh, right. Well, before I do that, let me actually put the properties on it. Right there. See this? You know, I just noticed something. When I got in there, I was fast in closing some dialog box. That's why what happened is that the static disappeared from here. Let me show you. Let me cancel that. It's better if you go back to where you were. Here, look what I did. Generative structure analysis. Say, okay, I think last time I probably said cancel or something like that. I don't know. There, this was missing. So let's try it. First of all, we mesh it. 0.5. See, this guy disappeared on me last time. It was dim. So probably I inadvertently close this thing somehow. Okay, clamp the bottom and this. Let's mesh this thing. It's already meshed, but if you want to display it, it's right there. Mesh visualization. It's already meshed. It's just that it's not displayed. That's all. Deactivate that. Deactivate it. Okay. Now, I want to symmetry. These edges are in symmetry plane, but not this symmetry plane for that. X, Y symmetry plane of the local coordinate system. So let's do that. User defined. Uncheck all of these. Uncheck all of these. Okay. So I'll say symmetry just so that I know what I'm doing. Symmetry. You select this edge and that edge and that edge. Now, let me hide this axis system because that's blocking. Or you can go down here and select it from down here, either way. And these edges lie in the, not the global coordinate system, user coordinate system, this coordinate system. They are in the X, Y plane. So no displacement in Z. See that? Perpendicular to that. Rotation is opposite, just like what you were doing, except that with respect to this coordinate system. Now, the next thing is I want to push this thing, okay? So there's two ways you can do that. One is do it on this side, the other one do it on that side. Either way, you have to be careful so that by mistake you don't select the coordinate system here. See that? Here's what I mean. First of all, let's hide this. Hide it. Okay. So user defined, user coordinate system. Remember, you created a coordinate system right now. It's hiding. Go get it. There we are. Here. There. There. That coordinate system. Go back there. In the direction x, this was x. It was x like this. So direction x is 0. Let me bring this thing here so that you can see it. So let me bring this thing here that you can see it. You see this? Direction X. Now, the one thing you have to be careful when it comes to support, don't select this point. Make sure you hide that guy and then select that vertex. Okay? Because if you selected that point of the origin, you're gonna get a warning message or something like that. Actually, error message. Okay. Now this is 0. This is 0. And I'm gonna call this thing push. Push. And now I can change. And the problem says this is being pushed in the direction X. X was like this. If you're going in that direction with a minus, because X was sticking out, I think, in this direction. Let me just check that. It is being pushed this way by 0.01 inch, negative 0.01, because X was pointing that way, I'm pretty sure. And we say OK. And this is it. So let's save the analysis, file, save management. This is the analysis, save as. There was already an analysis here. Yep, except that I'm going to call this thing problem 2. Say okay. Did I specify the thickness here? I did not. So let's go to the 2D property. This, I think the thickness of this guy is oh, 0.5 inch. So let's go here, 0.5 inch. Save it and run it. I did have symmetries here, except that I hid them so that you can see it right there. If you bring it in the front, you can see that. See that? There were symmetry conditions there. Okay, so run it. Done. So look at the deformation. You don't have to be brain surgeon to do this, rocket scientist to do this. Actually, maybe you do, I don't know. And look at the deflection. Tiny, however, this thickness is also very small, and the properties of steel. Okay, this it's kind of hard to say here. Look at look at the stress, 1 meter stress, and you can see this is 24,000. 24,000. So the moral of the story is that you got to be careful. I mean, this is what happens to you. Okay, this is what happens. There's no doubt about it. It's just that this deflection may be so big. We're pushing this so much that material may yield. If it yields, of course, these things don't make sense, and whatever we have done in CATIA is totally useless. Okay, but anyway, I've shown you how to do this problem. That's really the bottom line. Okay. Uh, Now notice that uh, if I reduce this thickness, for example, if I make this thing 0.5, that's quite thick actually. The other thing is that the reason that this looks ugly is that you're pretending that you're pushing this one node by some amount. There is no way you can push a node. If you want to push a node, you have to put a something very sharp there, like a needle, and push it by 0.001. So be careful about considering stresses underneath the uh, immediately underneath the concentrated force. Now, what I can do is that I can stay away from these. Let me show you how. Using a group, I can create a group properties. Let's create a group. Let's do a box group here. Right there. Resize the box. Let me see. Where is the handler for this? Let me move this thing a little bit down. Okay. Okay, so we're going to stay away from that end where we have gigantic stresses because we are applying a concentrated force. Say okay. And now if you want to look at the 1 meter stress, activate it. Okay, don't show me everything, just show me the box group. I say okay and hide the box group. So you can see those stresses at the corner was so much that it masked everything else. Whereas here, there's stress is pretty low. Okay. All right, so this is it. This is homework for lab 51. Please look at 52 and 53 and 54. You have 4 times the opportunity to see other problems.